move, you will see that these particles start to converge and do, you won't see like not of much of them. And the other thing we have is this is the pose with the covariance. So this will indicate the pose of the robot. That is think what it is. The way of interacting with the arbit is a little bit different. The buttons are mapped in a different way. So with the wheel, you can zoom in and zoom out. And with the left click, you will see that you rotate. And with the middle click, you rotate. So the left click and the middle click are swapped in from the Gazebo client. So what we can do with this? So the easiest thing to do is to command the robot to go to a place. This is done with this command, 2D nav go. Please be aware not to put this because the robot will think that is in another place and you have to select it again. Afterwards, we will do it again in order to an exercise because it's quite easy to do that. So we're going to ask the robot to go, I don't know, around here, for example. So, and you can see this is, you can see the arrows starting to, and we're going to Gazebo, and you see, well, this is not the best. Let me check if we can remove the ground plane, at least link not showing. View, let's go hiding, transparent. Okay, well, I don't know, but you see that the robot is moving here. So if we close now, something has appeared. So this thing here is the cost map. The cost map is something used by the move base in order to avoid obstacles. This is like, I cannot go through here. So for example, let's go, and I'm going to play a little bit around just to put, I don't know, let's go to put here a box. You go here, I'm going to place, you can place whatever you want, and we're going to see on the others. Let's go and let's command the robot to turn around. So the robot will, now you see the box. So in order to see the move base in place, we're going to ask the robot to go to this position, and you see that it's going to try to put the, and we have the local planner, have the global planner and the local planner, and now the robot is trying to turn. So let's go. Sometimes if I have a very special, let's go and help the robot a little bit because it's a little bit stuck. Going to go here. So now the robot now can go here, but you can see it doesn't collide with the box. So you can see here that the robot is moving. So the last thing you can do here is to interact with the console. So let's go to do this, and we can see some topics. kubectl get SPC. So if you have an SSH browser, let's go do it in another way. kubectl get pods. So we're going to go here. I'm going to enter this pod. You have to select this, copy, and kubectl exec --it, select the pod, No, sorry. I have to select, I have to puzzle this. I'm going to select this. Okay, Ctrl C, Ctrl V, and we're going to do bash. Okay, IT maybe. Yes. So we are going to, so we're having a console. So if we go source OPT, okay, let's cross topic list. Okay, source cross entry point. Okay, let's see if how we have. Now we have all the topics. In ROS, for ones who are not familiar with that, we communicate through topics. So, but for example, if we have a ROS node is like a piece of software. For example, if we do the ROS node, we can do ROS node list. We have all the nodes here. And if you do ROS node machine, you will see that we have these IPs here, and this is the IPs of the pods. Let's go and go to check that. kubectl get pods -OY, and we will see a little bit of information. So as you can see, for example, the 62, this one is this one. So this one is the ROS master. But for example, this one is the gazebo server. And this one, the 38, is the arbit, because we have arbit and they create some nodes. But for example, here we have 233, this is localization. And this one is the navigation. So we can see that we have the nodes distributed in different IPs. And if you see, this node is placed on this node, this ROS node, or this pod is placed on this. But our ROS master is in another node. So we can use the distributed capabilities of the Kubernetes in order not to have a very big, powerful machine. So we have smaller ones. So for example, the Cloud SSH, for example, the localization and navigation, for example, they are in another machine, in another node, another Kubernetes node, and the simulation is running in another machine, and even the client is in another machine. And you see, it flows like it is like one unique machine. So this is quite powerful. So if we need to do another thing, another ROS node, we can deploy it in another machine. So you don't need a heavy server or a heavy machine in order to do that. You can distribute that. That's quite interesting for this kind of research. So as you can see, so let's do a little bit of troubleshooting. If someone did a mistake with that, if you do the 2D pose estimation, you will see that the robot thinks it's around here. It's the way to fix it is to place it again where it was, something I try and error. So, okay, not too much, a little bit, I don't know, here. That's pretty close. So if you move the robot again, you will see that the robot is starting to orientate. I don't know if, and now you see that the dispersion is less. So the arrows are quite close. So you can play around with this simulation, even though this is the basics. That you can develop any other node on the cloud. You don't need to have Linux. You don't have to need a special distribution. You can add your container in order to interact with this simulation. And we're going to do that in the next steps. So the next thing we're going to do is to create our own ROS nodes. So we're going to go back to our virtual machine, and we're going to install Docker. I'm going to do this. Is like I was going to explain a little bit. This going to install Docker with a snap. This is the easiest way that we can find, but you can install it wherever you want. But we recommend that. And we're going to reboot the machine in order to be 100% sure that everything is working. So let me go here and copy, and we're going to paste it here. So Ctrl B. Well, I'm going to close Gazebo because taking a lot of resources, but let's go. If it doesn't work, refresh your, maybe it's like I'm sharing. I'm going to refresh my VPC terminal. Now I'm going to, now we are talking. So we install in Docker. And reboot. So the machine won't be available for few moments, but okay. I'm going to check here, for example, if it's like a little bit of, okay, that's should be expected. So we're going to test that the Docker engine is running. So the ones who are not familiar with Docker, Docker is a container technology that will allow us, this is the most worldwide spread technology for containerization, and we allows us to create a Linux container without the need to install anything on the host. So we're going to check that everything is working. So we're going to do a test. So our Docker engine is installed correctly. So we're going to, okay, here. We're going to proceed with the next step is like to install the AWS client that will allow us to create, to interact with the private registry we're going to create. So let's go, and what we are going to do is I'm going to install unzip because this is not present on the machine, and we're going to download the Amazon web client we use in curl. We're going to unzip it, and we're going to, after we are going to log in. So let's go here, and now so in the meantime, we have any questions? For not at the moment. Okay, we think everyone is following up or not understanding anything, but I hope for the first thing. Okay, I don't know what is taking this so long because this is unzip. Okay.
Quick question. So, are we going to have a break in the middle, or we're going to have continue until that?
Sorry?
Are we going to have a break in the middle, or we will continue until the end of the workshop?
Let's finish this, and we are having a little break. Okay, let's finish this step. Okay, copy, and okay, let's put it in step by step. Okay, I think I forgot this one. Okay, so put it here, and now unzip, and